This isn't yours, right, Paul?
What? Yeah, this is mine.
All right, so I'll put it right there.
Thank you.
You hook it up?
Yeah, I'm hooking up.
All right. All right, kick off just a couple minutes early. Welcome to this month's meetup. That means grab a slice of pizza, something to drink if you need to refill. Grab a seat. How many of this is your first LVTech meetup? All right, so it seems like we get that a lot. So if you keep coming back, it'll just be a bigger room. So glad to have you this month. I'm assuming you all found us through Meetup, so keep an eye on that. And if you want to stay up to date with what else we're doing, that's pretty much the way that we schedule things is through Meetup. I want to say a big thanks this month for Cloudera, and they bought all the pizza, and they've got tons of T-shirts and water bottles and earbuds and pens. And is that not working?
Hold on, I think I know what the problem is. Keep on.
Okay. And they're also presenting this month, so glad to have them here tonight. So big thanks to them. Also big thanks. Wayne's not here. He's usually here. He's the person who manages the facilities here. And big thanks to Ben Franklin for letting us use their space. Look at that. That works. Impressive. And a note for next month's meetup is going to be our annual pitch-off for collegiate business plans. So we get the top entrepreneurial class. A lot of the local schools have some type of entrepreneurial program, and they have winners of their own pitch competitions. So those winners generally come to our meetup next month. They'll pitch in front of 3 people from industry, investors, people who have a good feel for entrepreneurship and business. I don't know if somebody from Ben Franklin's going to be on that panel, probably. So that's a really interesting meetup to go to. Also a nice meetup if you want to network and get to know those who are in the entrepreneurial circles in the Lehigh Valley, because they'll be there. A lot of companies that, though they may be established, also care about entrepreneurship. Will be there presenting as well. So next month's meetup is definitely a fun one to get out to. And I should also mention, how many of you know about the Northampton Community College's Fab Lab? So a good decent. There's a symposium. I think it's the National Fab Lab Symposium is going to be next month, 10th, 11th, 12th, and it's being held at the NCC Fab Lab, which, if you're not aware, the NCC's Fab Lab is one of the, if not the best and most well-equipped Fab Lab in the country. So it's really cool that it's here in the Valley, and if you are interested in that type of thing, rapid prototyping, the Fab Lab movement, things like that, I think there's going to be a open to the public activity one of the nights. So just keep an eye out for that. I'll probably send.
That was me testing.
That was you testing. The audio also works with the system here. So I'll send out probably an email with some details of that, so pay attention to the meetup emails as we get closer to that. And just a note before I kick it over to Tom, who will kick off the presentations for this evening. If you have any announcement that you think is relevant to the greater tech community, if you're looking for work, we used to introduce everybody at these meetups, but it's gotten, it doesn't quite work with a crowd this size. So if you're hiring, if you're looking for work, if you've got something going on that you think everybody could be interested in, we'll have a brief, like 30-second open mic at the end of this evening. But without me rambling on any further, I'm going to kick it off to Tom from Cloudera, and he'll be the first presenter tonight.
Hey, thanks, Tim. So I've been here before. I think I presented once, probably about 18 months ago. It was in March. Maybe it was a year or two years ago. I think it was last year.
Souter.
So we gave a kind of a sort of a Hadoop 101 type of talk. And it was just sort of kind of going into the core of the technology. I'll kind of touch on that briefly, but I kind of want to expand out a little bit and really kind of talk about this whole edge to AI story. Because I think it definitely sort of fits the bill of what people are trying to do today. And then a year prior to that Hadoop talk was a guy named Doug Edline, who wrote a book on Yarn, and he was giving a talk on Yarn. So we sort of come a long way in terms of this being the third meetup. If there's interest in this type of content and this topic, I am open to possibly doing something that's more frequent and focused more in the data and AI space. So certainly if it's something you're interested in. come up and talk to me after the talk today, and maybe we can get something going. So without further ado, let's see if this works. I'm going to try to do something here and see if it works. Did it work? Okay, perfect. So you kind of see it, but this is sort of my little play. That's why I want to get sound working. Awesome. I just made this. Maybe. Are we recording? Come back to reality here. Here we go. All right. So let me get rid of that guy because I don't need him anymore.
We need a logo on this.
Yeah, if I can figure out where my mouse is now. Okay, here we go. All right, so let me go ahead and dive in here. Go full screen. And I have this guy, I think. Make sure he works. Perfect. Okay, so even though we're Cloudera, really what Cloudera is, it's a combination of a company called Hortonworks and Cloudera. We're pretty competitive in this space. Our technology actually came out of Yahoo, so I'll get into that story a little bit, but I think because of that, what you saw previously with the advent of the cloud vendors, and to really make it to where we could compete better with them, that's really what brought the two companies together. I don't think if Amazon or Azure or Google is what they were today, then I think we would probably still be separate companies. The good thing is we're sort of going to be the standout here in terms of what we're trying to build in the open source community. I've been working with data for a very long time, probably since about 2000. So I've been along much of this journey that I'll talk about today, and I've seen the evolution. And I would say like where we're at right now is probably the most exciting time in terms of what I've seen in the industry. And I know, 2020, 2021 is just going to get that much more exciting. Paul is going to come up and do sort of a demonstration later today, so I'll let him talk and give an introduction about himself when he comes up to speak. So the agenda today, pizza. There's plenty of pizza. In fact, he told me to order 10 pizzas. I ordered 13. Free stuff in the back of the room. I'm then going to get an overview of really this evolution. It's important to understand where we've come from to know where we're going and appreciate that. Really talk about open source. I think that's so important in this day and age. Believe it or not, the open source, because of what it's done for the industry, I really don't think a lot of these cloud vendors would even exist today if it wasn't for open source. A lot of they're pretty much the foundation of everything they've built on is open source. So it's important that we continue to foster that community. Beast mode quotient, that's Paul. So he'll talk more about himself and what he does with this beast mode. More free stuff, Q&A, and then again, please take free stuff. So how did we get here? So we go back to when computing started to become very popular, probably around the 1960s. These network and hierarchical databases, sort of big iron, made a big introduction there. So it kind of looks like the file systems you see much of today. Around 1970s, there was more theory behind something called the relational model. There was a gentleman named E.F. Codd, and he published a paper on this. As it began to gain popularity, a lot of vendors got behind it. Probably the big one is Oracle. Oracle decided to form a company around this, and they're probably the most popular relation database today in terms of revenue. They actually started as a top secret CIA project, and then from that is where they got the money to form the company based on this theory. Certainly, there are a lot of players in the space. Probably out of that, probably rose in the 1990s to more 2000s was Oracle, IBM, and Microsoft with SQL Server. I probably should have put their logo on there, but I forgot. Although one of those technologies, Sybase or Informix, became SQL Server. Huh?
Sybase.
Thank you. That guy in the back pouring a drink. So 1990s, this is where open source started to become popular. So Linux, there's a guy named Linus Torvalds who created the popular Linux project. He just wanted to get Linux or Unix running on top of his cheap x86 hardware, and it was his project, and obviously is the most popular operating system today. It's behind many of the things as we know it. Open source relational databases came to fruition, MySQL and Postgres. And then, certainly Amazon, with the dot-com boom, and Sun Microsystems with Java and the dot-com boom. And there's a little company, Google, formed in 1998, and they really did think differently. So when you get to the 2000s, something interesting happened. So I would say the big thing is Google, in the early 2000s, created this own technology. They were finding the relational database technology could not scale to the data volumes required to be able to index the web and really make the world's information accessible and easily searchable. And so they had to invent this technology, which is leveraging cheap compute, cheap storage, being able to scale out to really an infinite number of nodes. And so they published a white paper called MapReduce white paper. I think it might have came out in 2004. And some folks at Yahoo read that paper. In fact, one of the gentlemen's name is Doug Cutting. He's a Cloudera employee, and he created the Hadoop project. And so he started working on it at Yahoo. A lot of people at Yahoo got very excited around it. And one of the gentlemen at Yahoo, along with the gentleman from Oracle, along with the gentleman from Facebook, and a gentleman from Facebook, Yahoo, Google, Oracle. Okay, so that's four. They formed Cloudera because they thought we could take this technology and make it where everybody wants to use it. It's open source. We'll put a company behind it. Obviously, Facebook, Yahoo, many others. Those companies could not exist without this technology. They just couldn't afford to go buy Oracle. And besides, that technology just didn't scale. And Amazon Web Services was created in the early 2000s as sort of a little skunkworks project in Amazon. I wouldn't say it was a skunkworks project, it was a bold bet, because they realized we can't consume infrastructure the way we're consuming it. We're a customer. Let's figure out how we can serve up our internal users better. And obviously out of that is how Amazon Web Services came about into the behemoth they are today. As you move more into the 2010s, that's where we got out of the open source databases and more into the big data technologies and the data science and the machine learning, and that's kind of where we're at today. Now everybody's talking about AI, right? Artificial intelligence. And so that's where we're at today. Another interesting point to reckon is, imagine all the data that's been collected up to this point, right? I think they're saying you go 2 years out, 90% of the data that will exist in 2021 has not even been generated yet. So we're in this exponential growth phase of where we're collecting more and more data to drive more and more insight, more and more actionable intelligence, and ultimately more things like automated decision making, really where companies really embed this in their DNA. So why is this so hot today? Well, a couple things are going on. Data volumes, as I mentioned, are exploding. And in fact, that red line is probably too flat. This should be a very steep exponential curve. The second thing is the cost of compute, right? You can get a chip now with, like, I just talked to a customer the other day, 60 cores on a chip, right? This is a customer buying 100 servers, right? Most people don't need 100 servers. They can get by with like a couple servers, and they're getting the amount of horsepower today that 10 years ago would have cost like 50 to 100 times as much money. It's more efficient. Storage is unbelievably inexpensive, not just with these big data technologies, but look at the cloud vendors with something called object storage, right? Like S3 and ADLS and Google Cloud Storage and so on. So they're really driving down the cost of storage, allowing you to store more and more data And then the software, open source. Open source, if you look at the cost of deploying the open source software, it's probably a tenth of the cost of the proprietary vendors, right? There's a reason IBM's struggling with Watson. People don't want the closed source software anymore. They don't. Or they want the open source software. That's the direction that they're going. That's where all the innovation is happening, right? A lot of these PhD students, I would say here at Lehigh even, you got a PhD student working on something, he's probably working on something with open source software, and if he decides to contribute it back into the community, it's going to be open source. Same thing, it allows him to collaborate with people at Stanford, all right? It allows him to not just collaborate with all these higher education people looking at PhDs and whatnot, but also collaborate with people at companies, right? Companies like Facebook, companies like ours, to really contribute. If you look at the open source technologies, a lot of that open source technology was created within the community. Like Facebook created something called Hive that allows you to query the data, right? Salesforce created something called Presto. Somebody else created something called Phoenix, right? So there's just all these technologies. LinkedIn created something called Kafka. So I'm not going to get to the animals in the zoo, but if you look at the ecosystem, it's very healthy when you've got people contributing back their innovation back into the community. So if you talk about some of the challenges that exist within most environments, they're very siloed. A lot of their data is spread across the organization, and it's not easy to get to. So you've got a lot of these very purpose-built applications, but it's very hard to interconnect all the data from all these different systems to get the insight that you need to drive some, sort of some modernization. And so the hardest part is this data engineering. How do you centralize all this data? How do you get it in one place? Without doing that, you're very limited in terms of what you can do. The other thing is you talk about AI as a hot buzzword. It's got a lot of things you got to do before you get there. So you might have heard of this word big data, but to me it's just data, right? There's just a lot of data potentially out there. I'm not talking gigabytes, it's terabytes, petabytes, exabytes in terms of the amount of data that people are generating. Think about cybersecurity as an example. There's a ton of information for somebody to understand what's happening within their network and their environment, especially when they've got stuff on-prem, in the cloud, with mobile devices, Internet of Things. So there's just a lot of data out there. Analytics, right? So how are we analyzing this data? How are we getting value out of it? This could be like the traditional SQL, like a data warehouse, the traditional BI, you're using a Tableau or some kind of BI report where you're really kind of understand what happened, maybe why it happened. But then you start getting into data science. Well, instead of looking backwards, let's start to predict and automate decision making. What's likely to happen? So, think about a higher ed. We're at Lehigh. They can predict when a student is likely to going to run into trouble with a course or possibly drop out or churn. Mobile manufacturers or a cable company is going to find out, be able to predict which customers are more likely to cancel their service. Being able to predict which maintenance. We've got aircraft companies out there like Lufthansa, who is collecting all this data off of their airplanes, right, and trying to understand like what's going on with all the engines, all the metrics. Are we finding something that indicates that there's some kind of problem, some kind of early warning? And so they're trying to predict these things to become more efficient and more accurate. And so data science is one aspect. So I can leverage a lot of open source tools and put it on my laptop and kind of play around and do some analysis. But machine learning is sort of this intersection of that, where I talk about compute is cheap, storage is cheap. So it's taking data science, but applying it to a very large problem where I'm leveraging distributed computing to really be able to work with the data that I have to do the data science things at scale. So that's kind of what it's all about. But it's sort of leveraging a lot of the tooling to sort of help build and automate these things. So how you build a predictive model, how you update that model, how you manage it. So machine learning, I think, is probably the most important thing, because when you talk about AI, machine learning is probably the most applicable part of AI in terms of being able to learn from your data and from that be able to make predictions of what's likely to happen. And so that seems to be the holy grail. That's where a lot of organizations are trying to get to. And really, if you think about the future, if you think about, I talked about Amazon. There's a term now, Amazon. If Amazon enters an industry, it's very disruptive to the companies that are there. We've seen what they've done with retail. We've seen what they've done with technology. And so and they really make good use of their data. So the companies that survive in the future versus the companies that fail, the ones that win versus the ones that lose, it's going to come down to how do they leverage their data and what do they do with it? What kind of decisions do they make based on that data? So it's very, very important. This also came out the other day. This was very interesting. So Indeed, if anybody's familiar with Indeed, it's one of those job websites. I know a guy at Indeed who works for Cloudera now. They have like big, massive Hadoop cluster that manages a lot of this data. Number one job, machine learning engineer. One is for the percentage growth. So obviously this is an inflection point where a lot of companies want to get to, and there's not enough talent. Two, if you look at it, it's probably the highest paying job in here, because it's probably the hardest job, right? I don't think it's that hard. I just think there's, and I'll get into this, but there's a couple of, it's not just so much knowing the algorithm, there's a lot that goes with it. So I'll get into this. So Google gave a talk at one of these like deep learning conferences, and if you look at this, right in the middle is the ML, but this is an ML system. So this is everything that goes into building a machine learning system so that they can make predictions. And if you think about it, 5% of it is ML, 95% of it is building the platform, ingesting the data, scrubbing the data, getting into the right format, doing your feature extraction, getting your tooling and everything in place, right, so that you can be able to do machine learning, right? So this is why that job is the hottest job out there, because you have to kind of know what's going on in this area. So it's really sort of being a little bit of a jack of all trades, but you've got to be able to go deep in some key areas in order to be successful. And this is constantly evolving. 6 months or a year from now, there's going to be some new hot framework. So right now, Apache Spark is a very, very popular framework. But I've even talked to the guys who created Spark. They were interns at Cloudera, and then they formed a company called Databricks from the Berkeley Labs. And they're even telling their people, like, we don't know if Spark's going to be here in 2 years or 3 years, how fast things are changing. There could be something else that comes along that's now the next hot thing. But we're going to be prepared to pivot if that's where the market wants to go. So that's the thing, is you just have to stay on top of this. This is a constantly evolving industry. I don't even know why I put this in here, but maybe I'll go into machine learning a little bit. I don't want to get into this, but obviously Alan Turing kind of started this whole thing, can machines think? This is the whole AI thing. And certainly, this is sort of where you kind of get into it, but the whole idea is machine learning is not a one-size-fits-all. You have to understand what problem you're trying to solve and being able to apply the right application of the technology to get the outcome that you want. And so it really comes down to, but at the end of the day, it's not only the algorithm, but it's also data-driven, right? So making sure that we've got the right data, it's quality data, obviously garbage in, you can get garbage out, and there's a lot of different applications, everything from natural language processing, understand speech, text, that sort of thing, to looking at anomalies like cybersecurity or preventative maintenance on a vehicle, everything, self-driving cars, right? So as we become more and more autonomous, it's going to leverage more on these technologies that are open source to be able to build off. And again, nobody wants that black box approach. They want to understand what the technologies are that they're working with and being able to actually look under the hood and see the source code if they have to really understand what's going on. Some general problems. There's some people here in the back of the room that were having some machine learning conversations. So certainly these are the different types of problems that exist. So classification, is this a cat, is this a dog? Is it a hot dog, is it not a hot dog? Everybody's watched Silicon Valley. Clustering, regression. Everybody took a math class, especially algebra. You probably got into linear regression, maybe in logarithmic regression. Certainly, kind of go on, so on and so forth. But there's a lot of different areas, and there are people out there that exist that just do a PhD in one area. Where the technology has come from, though, is at a high level, you probably want to understand what problem you're solving, so you apply the right pattern. But a lot of the technologies anymore, they've got all the algorithms built into it. So Spark, for example, you write like 4 lines of code and you start building your model on your data set. So you got your data set in there, it looks like an Excel spreadsheet. You can start training your model as long as you know which one of these to apply to the problem, and then be able to actually create your model and then train it against a data set where you already know what the answers are and compare it to what it predicts. And if you feel like it gets a certain number of those answers right and it matches the answers to the questions, then that's maybe where you feel like, a model is a good fit or not a good fit. Not going to get into that. We probably do a whole talk just on machine learning. So a couple of guiding principles, kind of get out of the weeds a little bit. So one of our co-founders is a gentleman named Jeff Hammerbacher, and he probably coined this, he actually says he coined the term data science as a joke. Because people are asking, like, can you describe what you're doing at Facebook? And he says, oh, it's like we're data scientists, right? And it stuck. And his team was responsible for creating Hive. They're responsible for like Cassandra, a lot of the popular open source community projects that exist. But he was one of the 4 co-founders at Cloudera. Now he's off trying to solve cancer and genomics using the big data technology. But these were things he learned from working with data at Facebook and with customers at Cloudera. And I think they're really important to kind of have as principles. So the first thing is instrument everything. So that means we need to collect all this data that's being generated and centralize it. We need to get it into one place. 2, you need to have your developers make sure that they're instrumenting their application. So it's not just so much, we see that somebody came to our website, they clicked on these links, and they bought this. But like, what was the response time? What were the orders? What were the other things that they're doing? Trying to really understand the user experience. Right? Let's collect as much data as we can so we know everything we can about that person or about that device or about whatever that we're collecting information from. Could be just log files from an application. Let's gather that data. So that's part of instrumenting it, is making sure it's there and then trying to gather it. Invest in infrastructure. So there are a lot of places where they go out and hire a really expensive data scientist, maybe not an expensive data scientist, and they give them a laptop, but then they don't give them the actual infrastructure to be able to move beyond data science to something like machine learning, being able to get all that data in one place, being able to invest in resources to actually make a difference. So, you know, people's one thing, but you got to make sure that you're also investing in the resources to make those people successful. Put all of your data in one place. This is huge. So we have a bunch of data scientists within Cloudera, and I talk to them. And the number one thing that they run into is when they're trying to help customers be more predictive, they find that 9 times out of 10, that all the data that they need to work with is not centralized. So they've got a data engineering problem they have to tackle first to be able to get that data in one place so they can actually do something with that data. Data first, questions later. People can get held up in trying to think about their use case too much and thinking about trying to be absolutely perfect to go deliver on it. And sort of it's that paralysis analysis. You know what? There's a good strategy out there because this storage is so cheap. Let's just start grabbing data and getting into one place before we even know what we're going to want to do with it. We want to get to a place where somebody comes up with a question and they can answer that question very quickly because the data is already there. Data first, store first, structure later. So the other thing is, don't think necessarily about what format you want to get the data in to use it. Just get it into that single place. That person who's trying to answer the question, as long as the data is there, they have the ability to at least transform that data or process it or get it into some format that's very useful. So again, don't think necessarily about what formats it's in. As long as you can get it into the platform, you get a lot more agility that way. Keep raw data forever. So a lot of times people will aggregate data to try to save some space, but you lose the fidelity, and you really lose a lot of detail. So you might understand like how many sales you had in a day, but now you no longer understand what were your sales by hour in the day because you've aggregated it up. So you lose a lot of the detail about what's happening within the system. You sort of hide exactly what's happening. Let everyone party on the data. So let's get as many users as we can within, with responsibility and data and security and governance, but get them to where, if they want to bring in a Tableau or they want to bring in their Python or their R or whatever it is, they should be able to authenticate into the system, be able to access data that they've been given permission to access, and then be able to answer those questions. Otherwise, you've invested in a lot of infrastructure, you invested in a lot, but you're not getting the full value out of the information that's there. And then produce tools to support the whole research cycle, because this is an iterative cycle, and Paul's going to show a good example of this with the Cloudera Data Science Workbench and NiFi, but there's a lot of tooling out there in the open source community that makes your job a lot easier in terms of what you're trying to do with the data. So obviously, because of this approach, you want to get, once you have all that data in one place, now you can bring the applications to the data. You can bring the analysts, the users, the data scientists, and you have multiple frameworks that they're going to want to use, but they're leveraging a single unified platform that lets the data scientist work with the data scientist tools, lets the analyst run their Tableau reports, lets an end user work with some kind of application that's working with data within the platform. So that's kind of the big idea. And once you have all that data in one place, it's much easier to secure it and govern it. So I would say within open source, all the security exists within open source as well. So when we talk about this edge to AI story, we're really talking about not just your data sources here, but we're talking about what's the process to ingest that data. Certainly there's a lot of tools that exist. Paul's going to show NiFi, which is probably the most popular tool in this space, whether it was open source or not. It makes it really, really easy to get data into the platform, either in a batch, like a traditional ETL once a day, or real time. As soon as that data is generated, let's bring it into the platform. The synonym I would use for that is, how much is yesterday's newspaper worth? Probably not a whole lot, right? Newspapers are in a lot of trouble because people can go online and get access to information or on their mobile device immediately. I get an alert as soon as something happens within minutes. And so you can think of that as this is real-time news cycle versus how news used to be distributed, where you'd have to wait till the next day to get the news, right? So we're moving to this more real-time world. And then, of course, how you consume that data, pretty much that's the users partying on the data on the far right. You sort of bring your own tool, right? Certainly provide tools, but you give them the freedom to also be able to bring their own tool if there's something very specific they need to use for a job function or a task. And then talk about the unified platform. This doesn't touch all the components. And when I talk to a customer, I very rarely ever get into the weeds here, but it's good to know like what the different projects are. The majority of these projects probably exist in Amazon with some different name. They give a lot of these different names. But if you think about it, I would say like 80% of what's in Amazon is probably from the open source community. They just don't keep the name. They kept the Kafka name because it was so popular. If they didn't come up with a name like Kafka, people probably wouldn't have used it as much. But everything from how we ingest the data, to how we store and process the data, to how we do analytics and machine learning on the data, this all exists within open source. In Cloudera, for example, we deliver this as a single unified platform where all these components and other components are within the platform. That's where we fit, is that we're trying to deliver this platform where it runs, whether it runs in Amazon or Google or Microsoft or IBM or Oracle or on-prem or private cloud. It's the same experience. So that's our differentiator in the market, is that somebody doesn't have to go off and learn EMR. They don't have to go off and learn Dataproc with its nuances, or HD Insights, which are Microsoft, Google, and Amazon's version of Hadoop with the components around it. But these are the core technologies that most organizations are building on top of today, whether they're using these natively or they're using a lot of the native cloud services. These are really the underpinnings underneath those services. So multifunction. So there are some cloud products out there you may have heard, like a Databricks or a Snowflake or a Confluent. And while they kind of fit in one of these areas, one of the powerful things of leveraging Hadoop today is Hadoop is more of an ecosystem. Hadoop as an individual technology is really used for like the file system and some of the resource management. But for the most part, they're leveraging a lot of the best of breed projects that exist in the ecosystem to be able to deliver to the data scientist, to a data warehousing capability, operational database. I'll get into operational database specifically, something called HBase as an example. Data engineering, I touched briefly on that. It's how you process and work with your data. And then, of course, getting into other services that you want to build. And then being able to leverage this open source technology, whether it's on HDFS, which I'll get into, or the object stores as well. So there are pros and cons of the approaches. This is a technology where, I don't know how to say this, if you don't know what you're doing, it can be frustrating. But if you know what you're doing, it can be amazing, because there are so many amazing things that you can do. And there's tons of tutorials and tons of information out there. You almost have to pick one and kind of run with it and get good at it, and then find out, like, okay, this doesn't fit for the problem I'm trying to do. What's the next best thing? So I'll get into that in a little bit. So I want to go into open source now, into some of the technologies. Paul's going to go through a couple of these in his demonstration today. but kind of go through this. So is that foobarred? Oh my goodness. Give me a second, I gotta fix that. Didn't like my stuff. Bear with me. I'm using a font that it just doesn't like. There, much better. So this is what HDFS was and Hadoop looked like about 10 years ago. And the whole idea behind Hadoop was we have a bunch of, and this was based on what Google was doing, but we have a bunch of scale-out servers with storage in it, just cheap commodity servers like Dell servers, white box servers, and we would spread the data across many machines, and then the algorithms would distribute the processing to run where the data is. So you're not having to bring all this data across a network pipe. So move the processing to the data instead of the data to the processing. Very popular, and this is still a popular architecture today, especially for customers that are hundreds of terabytes, if not petabytes, or even exabyte scale. They're still going to leverage this architecture because those other architectures are still going to run into issues once you get to a certain volume or a certain size. So this is still here today, but this is not a one-size-fits-all approach. There are customers and users that don't have as much data where they might want to go with more of, let's leverage hardware in a cloud that we can use for our applications and our Hadoop clusters and everything else, and that's more of a decoupled compute and storage model. So again, this is kind of where a lot of this work is going, is sort of going back to the traditional model, but this is still very prevalent today where, again, scale out architecture with storage, run the processing where the data is. And this is kind of where sort of what HDFS looks like, a little deeper in the weeds, but you sort of have your file space up here. I'm not going to get into exactly what we call it. So it knows what the files are in the file system, and then it knows where the data is that makes up that file and which node it's on. And that data is spread across many nodes at least 3 times. So when somebody comes in to read that file, he'll actually give them the 3 locations it's in, and he'll just basically spread his reads out across many nodes and be able to read the data much faster, process the data much faster. So that's really what HDFS does. And if one of these nodes fails, so what? The cluster keeps running. Right? It's designed for cheap, inexpensive hardware to fail. So that's the whole idea behind traditional Hadoop. And a lot of your data warehouse architectures look like this. So Oracle's Exadata is pretty much the same thing. Teradata is the same thing. Netezza is the same architecture. So a lot of these big scale-out data warehouses leverage the same concept of spread the data across many machines and let's move the processing down to where the data is. So today, this is what I mean by the decoupled compute and storage. So not only do people want to run in that physical world, but now they want to run on virtual machines. They want to run on object stores. So certainly you can see where we're going. Now the whole idea behind the open source is people were able to contribute these things within open source. So if somebody's like, I want this, and they come to Cloudera and they say, I need this, but we don't have the bandwidth to add what they need. If it's open source and they've got a developer, they can go create the project, the change, and commit it upstream. So that's the benefit of open source and how a lot of this technology came about. This isn't controlled by any one vendor. It's controlled by many vendors, many individuals, many organizations and companies that if they want something bad enough and they have the resources, they can go contribute it back in the community. For example, Netflix contributes a lot of technology into the Hadoop ecosystem because they leverage this technology to do things like store a lot of their user data in terms of what people watch and be able to use that data then in turn run their recommendation engine. So you go to Netflix and they're recommending new shows for you to watch based on your past patterns. They're also looking at what other users across their population watch so they can make that so recommendation engines is a good example. They also use the data to decide what new shows to invest in. So if they know what people like to watch, they know, okay, let's go invest in these shows and create new series and seasons because that's what people want to see, right? So a little deeper in the weeds, so we talked a little bit about Hadoop and as a core. Where you store that data is a number of different formats. So certainly you can store it in your default XML JSON, but this is where people start transforming their data to do data engineering. This doesn't scale too well when you go to process it on lots of machines because you can't split the files. Certainly you can do that with text and delimited and kind of default. But then there's these other file formats here that are very optimized. So this is a little bit of ETL-ish, but you transform the data into a format that makes it a lot easier to scan that data very efficiently and divide the work across many machines. And so the nice thing about these is all these formats are, again, open source formats. So if somebody wants to add a feature to one of these file formats or some indexing or whatever, they're able to go into those formats, make a change, and contribute that upstream into the project. So based on this, I mean, you get pretty good compression, you get a lot of capability, and again, you know, I worked at Oracle for a long time. We didn't have all these fancy formats. And if we added like one feature to a format, it was like a big feature, right? But these all exist. What was really nice is Hortonworks was on Orc, we were on Parquet, and we were just competing, trying to make our formats better and better. And then once we merged, it's like, hey, guess what? We have both formats now. So that's the beautiful thing about what's happened within the open source community.
I like the working on ACID transaction. It's working.
So they're working on ACID transactions next. Oh, very good.
Yeah, it's been working for a year, man.
I know, you got us beat. So now you're us.
Yeah, that's fine.
Good. So now, obviously, where Hadoop is going is more like real-time, like OLTP type of workloads, more ACID. So at some point, a bank could probably run an ATM transaction on this if they wanted to, and be able to take money out of an account and kind of update multiple tables at the same time. Let's talk a little bit about pipelines. Paul's certainly going to touch on pipelines today. To me, a pipeline is just it's just an ETL process. You're defining like how you're taking data from one area and moving it to another. It gets a fancy name pipeline because people have moved more to real time. So as soon as data is generated, bringing that data and piping it through the system so it gets routed to its destination. And in the process, if you want to run some kind of analytics on that data, so maybe you got a machine learning model you built and you want to score a real-time transaction for fraud, this would be an example of like where you kind of bring it through the system in real time. So to me, data pipeline is just now ETL process, but with a real-time capability. So they really don't separate them too much anymore, because a lot of times now you're using the same tech, whether you're doing it in batch or real time. Obviously, being able to kind of handle this data, do the governance, and then at the end, obviously, any kind of analytics you need to do with the data. So piping it in, but also making it available. So if that data lands and I run a query 1 second later, I see the most up-to-date information that's in the platform. So that is really the value of real time, but also kind of when you combine that edge component all the way to where you do the analytics, including possibly the machine learning or AI, it kind of fits within that pipeline. And then last but not least, in terms of pipelines, actually I got a couple slides on this. So this, I think, is the most impressive in terms of streaming ingest that exists. So this will connect to pretty much anything. Work with any kind of file format. Somebody had a question, MQTT. You probably want to look at NiFi to see if it can work with what you're building in MQTT if you want to move data in terms of IoT. I even saw some stuff from Amazon. Some of the Amazon people were talking about some of the stuff that they were building. And get this, these are all Amazon components, right? I'm surprised they didn't take NiFi and give it a different name like Ifin.
It's coming.
Yes. Amazon Ifin, spelled backwards, or Fini. But anyway, they're using NiFi a lot, kind of as this glue, maybe that's not the word I should use, that kind of helps enable a lot of this real-time data movement within the environment. But yeah, we're starting to see customers who don't even want to do Hadoop, but need this tool to move data from the edge to their cloud environment, move it into their object storage. So what's really nice about this is it's very GUI driven. So something that could take you weeks to do, all coding by hand, you could get done with very little to no coding in maybe 5, 10, 15, 30 minutes and have a pipeline up and running that you can monitor, manage, maintain. And then Spark. Everybody's heard of Apache Spark? So this is probably the most exciting component within the platform because this is what everybody's using to process the data. This is, I would say, the majority of people are using Spark to do a lot of their machine learning on the data. If I'm dealing with, let's say, a data scientist who wants to use Python or R, or even SQL, and they want to work with lots of data in the platform, what you do not want to do is put that data all into one CSV file and then try to read it, because it won't scale too well. You want to use an extension of Spark that those vendors have written. So there's something for Python. You use PySpark. You run Python within Spark distributed. That is going to scale much better. R, Sparkly R. Don't ask me where they come up with these names, but it's essentially taking R and leveraging Spark as a distributed engine to go and work with the data in a distributed manner. And Spark SQL. If I want to write SQL, I can write SQL within a Spark job, and it goes in and runs SQL against the data distributed across the environment. So again, if you leverage the technologies in the right way, you can take something that will take hours and days to run and run it in minutes or seconds if you have the right size cluster. It's all open source. You can go out there and read all the source code on Spark, and it's probably the most popular project within the Hadoop ecosystem right now in terms of how people are using it. Oh man, this guy is just butchering my stuff. So that says search. So is anybody here working with like Elasticsearch or any kind of search technology? Okay. This is probably one of the more popular things. So people want to get in a bunch of documents and they want to expose it to be searchable in a Google-like manner or do some kind of multifaceted search. But the key thing here with search is you sort of fit a different style of problem. So for example, you want to search against one word, but have it match other words that sound like it or that are similar. Search can help you find that data. It'll help create indexes and find that data. So Elasticsearch is now 100% open source. Well, I thought it was. They're going to war with Amazon, right? So something called DistroX.
No, they are open source, but Amazon just decided to do their own thing.
Yeah, gotcha. So that's interesting. So Solar is another open source search technology that's actually in the Cloudera stack, and it's very similar to what Elasticsearch does. And it actually uses HDFS it can use HDFS to store its collections. So a lot of these technologies will leverage HDFS to store the data, but yet you can now build search applications on top of the platform to index the data that's stored in there in some different ways so that people can actually find it or build some kind of search application. So this is a very popular, beyond like a relational database or those sorts of things. This is another type of engine and technique to work with data, and it's extremely popular. NoSQL. So everybody here heard of HBase? I'm sure they have. Mongo, Cassandra. So these are very popular like NoSQL databases. There obviously are some nuances there. What's very nice about HBase is it's a very, it's sort of really simple to me how they've architected it. Some of the largest companies, the biggest applications in the world run on HBase. I think I was talking to somebody, they've got a customer who's running like an HBase app. I think he said it's in the high petabytes or even exabyte range. Right? So this can run across thousands and thousands of nodes. You can have billions and billions of rows, millions and millions of columns. And it's very fast. It can support millions of transactions a second with millisecond latency. There's something called Apache Phoenix, which a lot of people like to run on top of HBase, and it makes it like a very fast OLTP type database.
Yeah, it re-enables SQL on top of HBase, and it has its own processing engine, so you end up having faster response on Phoenix.
So it's very popular. And this is where, if people want to build a mobile application, they'll use this as like HBase as the backend database for the mobile app. Now they won't have the mobile app talking directly to HBase. There'll be like an application tier in the middle. It'll probably be a REST API with JSON, maybe compressed JSON.
Spring
and
Boot.
Huh?
Spring Boot.
Yep, and then it'll probably be leveraging something like Node, right?
Yeah, Spring Boot and Node.
Yep.
Probably.
And that'll kind of be your buffer between your mobile device and your backend database, likely HBase. But it could be something else. If you're not building like something that needs very high throughput, you could probably build something like that, obviously, in MySQL or Postgres as well.
Yeah.
Yep. Man, I really butchered this.
Nice.
It's because hold on, I'm going to fix this. This is driving me nuts.
Workbench. I'm taking a guess.
Yeah, it's my machine learning is failing me. Hold on. This is really bad. I think I'm ahead of schedule though.
What time are we finishing?
All right, we're almost done, man. I'm almost done. Just give me some time.
No, I do.
All right. So one of the things that's very interesting here is people want these like IDEs, integrated development environment. Certainly there's RStudio, Python's got a bunch. And so one of the big things here that Cloudera came out with is something called Cloudera Data Science Workbench. I think it was probably the most boring name we could have ever come up with, but it kind of describes exactly what it is. And so the whole idea is you've got this Hadoop cluster with lots of data in there. We don't need a data scientist putting a bunch of stuff on his laptop and then trying to connect to the cluster and pull stuff that's terabytes or petabytes out of the cluster. This lets him come into the environment next to the cluster, run his analysis, uses Python, uses R, uses Scala, use whatever he wants to use that fits within the framework, and then he can leverage and work with that data, analyze that data in much more efficient ways. There's other things in the tool like you can collaborate, you can create projects, you have security. So there's a lot of benefits, but this is just using a web browser versus having to install a bunch of stuff on the laptop like I've done. I've got all kinds of crazy stuff on my laptop. I probably ruined it. You can see by the language it's throwing out there, it's probably something I did. But this is definitely something that works with Docker Kubernetes, and it's going to be an open source project here in the near future. We haven't open sourced it yet. Oh man, I really messed this up, didn't I? This is all screwy. Whatever, I'll get through this. The whole architecture behind the CDSW, actually this is really messed up. I can't do this. Hold on. I fixed all this earlier. This is just, it's not liking me. I probably have a virus in my, let me go to the next slide. Yeah, this is really messed up. Bear with me. Here we go. Yeah. I should just pick a different font. All right. It's all messed up. All right. We'll just run with this. Much better. So here's the other place that a lot of things are going. Docker and Kubernetes. If you're in the infrastructure space, or if you're a data scientist, probably something you want to get your hands on and get up to speed with because it's coming. Not just with the cloud vendors, but private cloud. It's probably the reason IBM bought Red Hat for $33 billion. This is where things are going. So VMware and OpenStack are kind of the old, boring way now. 10 years ago, they were exciting. And now everything's going Docker, Kubernetes. It's just, I can run a lot more containers efficiently. You're leveraging that architecture than leveraging the old virtualized architecture. And a lot of the platform components are starting to be built to be able to run on those frameworks. So that's where Cloudera's Data Science Workbench is going to run. But in the future, let me find this. In the future, this is where it's going. And it's, again, open source. So you can have this run as part of your Hadoop cluster, or you can leverage it standalone in a cloud or Docker environment, and it can plug into a Hadoop cluster, but it can plug into your object storage, it can plug into your relational databases. So this is where things are going. Probably the next 1 or 2 years, if a vendor is not making their technology compatible with this, with Docker and Kubernetes specifically, they're going to have a bad time, right? And again, Docker and Kubernetes are open source. Kubernetes created at Google, and Docker, I don't know where Docker was created. By Docker, maybe?
Yeah.
Docker.
Yeah. And then you go beyond that into the frameworks that people like to use, and I could not fit them all on here. But obviously, people want to work with like scikit-learn, RStudio, TensorFlow, PyTorch, and so a lot of these will work right within the platform, or they run within a framework in the platform. So I can't tell how many TensorFlow and Spark projects there are. There's quite a few. But people are essentially taking, somebody actually just got TensorFlow running on Raspberry Pi certified now. So again, there's a lot of places, and if you want to get into classification, dog and cat, and hot dog, not hot dog, you probably want to look at what TensorFlow is doing, because it definitely is used for those types of use cases. And again, this is where all the innovation is happening. So you kind of put all this together. It's sort of end-to-end. It's not just the core platform of getting all that data into one place and ingesting all that data, but it's also being able to tune and tweak your models. So again, we bring that data in, we update our machine learning model. Now take that model and run it somewhere within the data flow and make a decision on that data as it flows in. It could be score it for fraud, score it for risk, score it for something else, but being able to make real-time decisions based on data as it flows through the system, but then having all the security and governance to know, like, what are all the different versions of my models? What decision did it make? Why did it make that decision? What could we have done differently to make a better decision? And so it's sort of this reinforced type of learning that continues to happen within the system. So here's a couple examples of how you put these together. So this is just a pipeline bringing in some real-time data. KnifeLight could have been on this. But the whole idea is you're bringing it in using the streaming technologies. And then from there, you store it, depending on the storage format, based on your use case. And then from there, you take some kind of action. It could be real-time decision-making. It could be somebody wants to get the latest information when they run a query. You want to feed it downstream, whatnot. But this is sort of how you would connect the dots from a high level to put these pieces and components together. This one's a little more of how you would sort of drive your model through machine learning, and then as the data flows through, constantly updating that model. And based on that model being updated, you can then use that to run on the data as it sort of comes within the pipeline. So these are just high level, but the whole idea is that there's no one-size-fits-all component. It's how you sort of connect the technologies together, kind of like Legos, to create a solution. Any questions? Is that good? Okay. This is for my friend here.
Yeah.
Beast. We were in Seattle, so everybody knows Marshawn Lynch as Beast Mode. Now everybody will know Paul as Mr. Beast Mode. I almost put your face on his head. I decided not to do that.
Yeah, it could have fooled anyone.
That looks like you.
Yeah, if I was like a million pounds stronger, maybe.
Okay.
Thanks.
Thank you.
So what I set up here,
And there's free stuff, by the way.
I want to thank Tom for going through this, because it is there's a lot of information that was shared, but it's important because I'm going to show you an example of what I've done with this tech, but without having a little bit of a context. Point is, what I built here is a small experiment on myself, but this is a type of architecture that has been used at scale, and that we see people using in real life, not just conducting those small experiments that I did. So, let's see if this works. So this is a live demo, so probably it's not going to work, so just bear with me. Right? I have a few slides to explain you what I'm doing, but anyway, so let's see. We're doing it? We're doing it. All right, so I lead a kind of a similar meetup in Philly. Is this working? Yeah. Where I presented a little bit about this particular project, which is what I coined Beast Mode Quotient. But to give you some context, this is something that is really near and dear to my heart. I'm a runner. I'm actually running a marathon next week. I'm trying to just beat my time, and I've always been fascinated with science in general, the scientific process, and specifically science of training. Now, if you look a little bit in the literature, and I can give you a little bit of context about this, but what we find out is the best predictor for performance of an athlete is a subjective measure, which is how the athlete feels the morning before competition. So there's a bunch of meta-analysis on this where they look at blood markers, muscle biopsies, heart rate, HRV, everything, and you find out that there's more bad data in objective measures than there is in subjective measures. and especially inconsistency, etc. So a lot of the state of the science now is to say we should incorporate that into a training program. However, we don't know how to predict the way that our athlete is going to feel. So essentially it comes back to this beautiful meme that I did, and this is a lot of my creativity. So the subjective measures are important for performance, right? But they should be integrated with training. But there is no way to correlate objective and subjective measures. So that's what I set out to do with this little experiment that I did during my training. So what I did is I had this idea of I have a bunch of data that's available to me, which is my activity data, so how much distance I run, duration, the heart rate, the elevation, pace. I can look at my sleep data, my nutrition, and just more general health metrics. And I'm trying to correlate this to my perception of how I feel in the morning. And so every morning I would set up and just plug something into a database of how I feel in the morning, before workout, after workout, and in the evening, right? Now, I built, so this is, you can probably build this with 2 strings and a couple of Python and shell scripts, but I wanted to build it into an architecture that is scalable. So the way that I built it is, the way that I think about it, if I have all these sources that are essentially my edge, right? So this is Fitbit data, Strava, and MyFitnessPal. So there is a reason why I chose those APIs. It's because those are the ones that are open. I was running on Garmin. Garmin, you need to pay $5,000 to get access to the API, like just right away. Or they give you a proprietary .fit format with an SDK, which is a pain in the ass. Don't recommend to use it. Whereas Strava and Fitbit are kind of open, so you can just plug the data in. MyFitnessPal, you can just export a CSV, it's fine. I looked at Apple Health as well. And Polar, same problem as Garmin, it's very proprietary. Apple, they give you the whole data, but they only give you a bulk export of the whole data from the beginning of time. There's no way you can go to Apple and say, hey, I just want to think that happened last night, or whatever. So it was kind of, I'm not reparsing the whole data all the time. So what I'm doing is, and this is a typical architecture, by the way, where you have a long-lasting cluster that will store and process your data with a model that is the fatigue prediction model. But then, so it's integrated in the pipe, right? So once I gather the data, apply the model, bring it back to my application, and that's where my application is running, my Bismuth Coach application. But then I want to refresh the model. And I wanted to show the ability to just launch an ephemeral cluster, train the model, bring back the model into my long-lasting cluster. Why is this important? When you think, I see a lot of, whether you're a startup or you're a Fortune 500 companies, storage is cheap, compute is not in the cloud. That's the reality, right? So you want to be able to have the elasticity, take advantage of the elasticity of the cloud and the separation of compute and storage. But it's very complicated to build applications that can do this across clouds. So you need to have, and the best way to do this is to use the components that will work on every cloud, which is leveraging open source. So I built the ability to launch a cluster, train a model, and bring me back the results using Spark and Zeppelin. I didn't have Data Science Workbench at the time. When I started, I was working for HotelWorks until a couple of weeks ago. And what I used to deploy those clusters is technology called CloudBreak, which is also open source, which allows you to just really deploy those configurations. And then I built an application on top of it that's running on containers that does all this. The way the application is working is this. So typical architecture, I have a user connecting to the front end. So the front end is React, and I'm using a bootstrap called Core UI. Backend is Node.js, and then this calls the different elements. I have a MySQL database that Spark uses to build its model, and I'm using CloudBreak to spin out the ephemeral cluster. and NiFi is consuming my local MySQL. And I can also download back to the file system via the browser. Make sense? All right. Now let's get into it. First, let's talk about data ingestion, which is the reason why John Horton works in the first place was because, full disclosure, I've been working in data movement for about 12 years now. I used to do like those big ETL machines with like big ass fridge that had a bunch of servers on them. But what I'm able to show you here with NiFi is really excites me. So anyway, this is NiFi. So NiFi is an open source project that is packaged as part of Cloudera Dataflow, and I had to set up to figure out a way to ingest data from multiple different sources, Strava and Fitbit API, and MyFitnessPal. So let me dive into an example, and I'm going to show you a little bit about how it works and what how you can build your own flow. Again, if you look at the architecture of NiFi, this can be run on a cluster. It's just a web UI that's just calling an engine that is Java and that has a bunch of extensible processor. Processor is where the compute occurs, and then between processors you're going to have flow files that will flow. For the guys that don't know, NiFi is it's a project that originated from the NSA. It was built after 9/11. It was built to process a ton of different files, route them very quickly while maintaining their provenance, right? So there's a lot of things that are automated, like back pressure handling and provenance. So let me give you an example. Here, what I'm doing is I have a MySQL database that is running here that has all my different data. And what I'm doing is I'm literally going to the database and saying like, give me the latest timestamp, the last time that it was my database was updated, right? And this is using a execute SQL processor. You could connect to anything. So we talked about MQTT, right? For instance, so this is just dragging and dropping a processor. Here I have an execute SQL, but it could be like consume MQTT, for instance, and I'm just going to connect to an MQTT. You could do Kudu, Kafka, whatever you want, right? Here, and you can connect also to CDCs. Like we have a CDC processor for MySQL. Obviously, we don't have a CDC processor for Oracle. It's not open, so you're probably going to have to pay for either a partner or like Golden Gate or whatever. But you can like ingest like this sort of feeds, and we're talking about operational scale, right? We had about trillion per minute or something on a Kubernetes cluster on the cloud. So this thing runs fast. So when you run, you'll see that I get a result, and so this is the great thing about managing your flows is you can actually look at the queue. You'll see that hey, I'm getting data back, and when I see it, I'll see like by default it will send it to you in Avro, right? So what you can do is do a first conversion and say, hey, I want to convert this into JSON to be able to read it more easily. This is something that is super important, changing between different formats. You talked about the ORC, Parquet, Avro, whatever it is, depending on how you want to push it. Usually in the flow, you want to be able to push in multiple different places. What NiFi does, the way that it works, is it stores the schema and the data in two different things, right? So that allows you to have 10 different formats from one data file. It will not read the file. It will just change the format, right? So you're virtually going to have a lot more processing power because it doesn't actually have to read the file, as opposed to many other vendors like StreamSets or the Informatica of the world. They are record processing. So every time they have to reopen, see the file to change the format. This changes things. And it also means that with what we do in Dataflow, we can have a repository where you have your schema and handle schema drift. So if your source changes, if your Kafka topic is changing, if you have different environment where you're going to have different format because you're in different versions, you're going to be able to simply pull out to a specific, what we call a schema registry. And you'll see that some of the I don't know a processor that runs this, but here you can have an auto detection, or you can refer to a specific schema registry, and then you're going to have the history of your format and etc. This might not seem like much, but if you are doing a little bit of data engineering, this is going to be crucial for you to be able to productionalize this, right? Because we're talking about enterprise grade. We're not talking about somebody hacking something in his garage like I did, but more like if you want to push it to a real production environment. Another thing that you noticed is that this queue is going to stay hidden here. But if I do something like, let's say, I want to do a fire hose. Let's do Twitter. I'm just going to get it from Twitter. I don't know, I'm going to do a generate flow file. It's going to be easier. I want to simulate something. So if I do a generate flow file, and I'm going to send it to to this, what you'll see is you have several settings that looks at the scheduling, how often it's going to be scheduled, right? And where it's going to be, how it's going to be load balanced, and etc. But the point that I want to touch on is, as you see, I generated 10,000 files randomly. You'll see that it stopped processing after 10,000. So if you have one part of the flow that is generating a bunch of data and you have a processor that takes a long time, it will take automatically it will go back and say, hey, stop, wait a minute to generate your data. Wait for the next processor to be able to handle it. And that's important. It's all part of the tool itself. You can decide how you're going to prioritize the queue, what's going to be the threshold, whether it's the number of files, the size, and so on and so forth. Do you load balance this queue across your cluster, and so on and so forth, right? So all of these considerations that are frankly hard to implement when you're doing it yourself with code or etc. are taken care of within this tool, right? So I'm going to empty the queue and delete it. Now, to go back to the flow itself. So what I'm doing here is I'm getting data from the source, and then I'm converting it to JSON. So now if I look at the file, I'm going to be able to see, this is the start time and the versus now. So this is the last time it was updated. And then I'm running a query that just extracting the data that I need. And this is where we get into calling an API. So Strava is using an OAuth architecture where you have a refresh token that will give you back an authorization token, and then you're going to be able to call the API itself. I don't know if you guys are familiar with API development, but it's basically authentication. And what you can do here is, so I'm refreshing I'm sending it a refresh token, right? And then I'm extracting the token from the response. It's a JSON file again. And then this is where I'm going to ask Strava to give me all the list of activities, right? Then from if I get multiple, so I'm doing like, give me the list of activity between the last time it was updated and now, right? So if there's multiple of them, I'm going to split them in 5 different files. I extract the relevant attributes, and I can do a little bit of conversion. So what I'm doing, for instance, is this is basically saying if there is no average HR, because let's say I run on a treadmill, I didn't have my HR on my watch, then put it to 0. This is converting meters into miles because we're in America, right? So, and then this is just creating a SQL query that is literally just taking the, oh yeah, this is what I should show you, I forgot about this. One of the the cool thing, I was talking about the file and the header and the file. When you look at when you look at a file in particular, what you'll see is you have the file itself, but then you also have what we call attributes. And attributes are the stuff that is put in memory, right? So the stuff that I'm using to build the query itself, like the start time, the duration, distance, all are taken not from the file again, they're taken from the attributes in memory, right? So again, you have, it goes very well with this architecture of store the raw data, right? Just store everything and just use whatever is needed to route, right? So after I do this, I create a simple insert. It's and you know, this is my SQL foo. So if there's a duplicate key, just freaking update, right? So because I just basically do an upsert and put it into MySQL. So that's how I ingest data. And so this, I've been doing this, and I run it every. I think I run it every 12 hours, right? And just keep it running all the time, essentially. Does that make sense so far, this flow? Yeah? Cool. All right, a little bit more specifics on the stuff that you can do in NiFi. The one other thing that oh, and by the way, those processors, a few things. So first, this can be version controlled, right? So we have, if you install NiFi registry, you can connect to Git, obviously. You can have multiple versions of the flows, and that will allow you to deploy from dev to test to prod, etc. Right? So you have the whole life cycle that is taken care of. And we even have in 1.9, if you use a custom processor, right? Because you can create your own. I created my own processor. It's a Maven archetype. You just download the archetype, and you get basically everything. You can have the processor run a ML algorithm inside if you want to. It took me like 3 days after I joined HotOnWorks to figure out how to do it. It's not that complicated. And I wrote a bunch of articles about it.
I would also add this. There's really good documentation and tutorials online.
Yeah.
This is something that anybody can leave here today.
Yes.
And go home and download it in 5 or 10 minutes, put it on your laptop and whatever, and start playing with it. Just 15, 20 minutes, you can start doing what Paul's.
Yeah, it's brew install NiFi and just you put it on your computer. It's fine. So yeah, you have all this handling, this version control and etc. And you can also build your own processor. So it's super extensible. Though the processors that are put out by the community are a lot more robust and tested. But you're going to be able to see, like, you know, if you look in the properties and the settings, like you can look at the documentation of it. You have you really what do you say these? Yeah. If you look at one specific stuff, you can see the. I don't remember the way to see the documentation. But anyway, it sends you to the documentation. It shows you all the different stuff. It's super robust. There's a lot of stuff around it. And you can do a bunch of cool stuff. So what you can do is here, like for instance, in Strava, the refresh token, once you have one, doesn't expire. So I can keep reusing it. In Fitbit, it expires after 12 hours or something along those lines. So what I did is I have a distributed map cache server, which is essentially a Redis server. Again, that is all controlled by NiFi. You can have a control service that says, hey, just generate a distributed map cache, right? That will hold certain data. And what I'm doing is I'm getting the latest token from the cache. If I don't find anything, I'm going to use a default value that I inputted in. Otherwise, I'm going to use from the cache. I'm refreshing the token, extracting the token. From the extractor of the token, I'm running the health and sleep, and I'm pushing it to MySQL, same way as Strava. And then there's another route that says, hey, let's put it back put the latest token back into the map cache, right? So you can stream, like you can have different stuff. And you'll notice that I have something that says success, matched, or unmatched. What you can say is like, hey, if this is a failure, right, report it to somewhere. So every processor is going to have different routes, and this really gives you the end-to-end of your flow processing. And this is, again, like if you try to do it yourself, this is the stuff that's going to be complicated. Now, the little brother of NiFi, well, I need to stop it. Little brother of NiFi is MiniFi, and MiniFi, the only difference is it runs just the engine essentially without the UI. So you can just take a flow and push it to a very small device, and it can be either running on a Java core or on a C++ core, so it's much smaller, right? And so you can run all of these little things on your device directly. Here I'm calling an API, but you can have small agents and different NiFi clusters talking to each other using a side-to-side protocol. So it's super fast. So if I want to add, for instance, what I can do is I add a remote processor, and so I specify the place of the server, and it will push it automatically over there. Now on the MiniFi side, before in 1 month, so in like 2 weeks, you're going to have this available EFM. You had to manage the fleet of small agents manually, but coming out at the end of the month, we have a manager that allows you to basically listen to all of your agents, and when you want to push another version of the flow, it will do it automatically at the next heartbeat, right? One other thing that was introduced in 1.9 is also the fact that if you put a new version of a processor, before that you had to stop the engine and restart it. Now you can hard push it, and a bunch of other stuff. Like now we're running on Docker container. Yeah, like I have a NiFi running on the container at my other computer. So, and with Kubernetes, one of the biggest problem with NiFi is like it's relying on the file system, which means if a node goes down, you need to bring it back up to process the last flow file. With the separation of compute and storage, now you're going to be able to have this completely distributed. So, and this is where you can get like ridiculous speed that you probably don't need. One last touch on the ingestion is the ingestion of flat files. The reason why I comment on this is because I want to touch on an important thing in NiFi, which is the state. So we have stateful processors. Stateful processor will be able to monitor a specific source for change. So here it's like listing a folder. Anytime it sees a file with a new timestamp, it will take it and put it into the flow. That also means if you want to do, you can have stateful processors that are looking at database changes or log data or web logs, right? So this is super important because now you don't have to do it something that is processing on a regular basis. The pattern is you list the file in the folder, look at the states. If the state had changed, then you trigger the flow, right? I'm excited about this, but you know.
I think one of the biggest things that you were talking about is we have customers who are going to be deploying these mini agents.
Yeah.
And they're going to be putting them in cars, and we're going to have people like manufacturers putting it
Yeah,
in
we already have,
and their trucks, and they're going to have like 100,000 agents out there, and they're going to be able to push updates and be able to collect that data in real time. So that's kind of where they're going with these mini agents.
And then you can imagine that here I'm pushing it to a SQL, but you can push it to Hadoop, you can push it to a Kafka topic to make it a microservice, you can put it like really anywhere you want, right? So it's, and you can have a feedback loop. And why is this important? It's because having this flow management also enables really the return of the feedback loop, and not only having the data scientists doing something at one end, but really being able to like use the computation that you've done. So far, so good?
Yeah, you got about 12 minutes. Not to rush it.
All right, fuck it. All right.
Can we go over a little bit, or 8:30 hard stop?
Nah, it's fine. So I'm gonna go quickly and then show you.
I eat all the time.
Show you the cool stuff. So the other thing that I solved the problem of data ingestion and spent a lot of time on NiFi because I like NiFi. The other thing that I used is so CloudBreak to be able to push data to the cloud. This is the way that CloudBreak is working. You basically specify a credential. So I have a credential on AWS here. You specify a blueprint. So I have a blueprint that says, hey, I want a one node, because it's only the one node with basically HDFS, Hive, Spark, Zeppelin, right? And then you click on create a cluster, and it will push the. And what I wanted to do as well is I wanted to preload the cluster with the data and a notebook in Zeppelin, right? So I created a recipe, which is a simple shell script that says, hey, so this is a bunch of SQL script, shell script, like insert the data and push something into Zeppelin. The result is once I've done once I deployed this cluster, I can go to the manager of the cluster, which is Ambari, and if I connect to it, you will see that I have maybe I didn't open this port. Shit, I didn't open this port on. I forgot about this. Oh, yeah, because I did that.
Live demos.
So, for those who are familiar with AWS and cloud deployments, I was connecting from my home, which has one IP, and I opened the ports for this one IP, but I'm on a different network today, so I'm gonna have to work on this. I want to make sure it works, because otherwise it's gonna fuck up the whole thing. So this is my EC2 instances, maybe. Right. So I have. This is where I'm running my. You'll see that this is where I'm running my instances. So if I look at the BMQ, which is this one. I look at the security group, and I'm going to say add all the things from my IP. We did it. So anyway, so now I should be able to connect to my Ambari. Maybe, if it loads. Will it load? And then see the cluster as it's being managed. So, and this can be, of course, this can be completely automated via CLI. And by the way, all of this, what I'm presenting here, all of this is available in this article where I detail this is slow. Where I detail the whole architecture, and one by one, like the ingestion part, the create the CloudBreak using Spark and etc. is detailed. So if you want to use like creating the right blueprints and etc. This goes into details of how do you create the service, how you create the recipe, how do you add a blueprint, how do you run this stuff. Everything is detailed there. In the interest of time, I'm going to pass all this and get into the juice. So the data science, this is the weak part, and also the perhaps the least interesting part, and I'm going to get to it a little bit. I'm going to jump on two things. So if you remember, I wanted to create an application that reads my data currently and try to predict my level of fatigue of my BMQ based on my objective data. So I created this small, my super password, damn it. I created a small dashboard here that looks at the data itself. So if you look, it's like, I'm going to touch on the indexes later, but this is kind of the way that I felt. So this is the BMQ per day. I was probably hungover here. And here too, or sick. And so what I found out is you can look at the way that I feel in the morning. Usually, after workout, I feel a lot better, which is good. You can also see like my average heart rate and my heart rate in the morning, my resting heart rate. Like here is where like the training was paying its toll. right? And if you compare to, this is where I was probably running 22, 24 miles, and then piling up like 80 plus miles a week, and that kind of like affects your recovery, plus with the stress of work and etc. It was kind of where we are. I also had the daily calorie intake and the nutrition percentage. I gotta be honest with you, I didn't include this in my models because I wasn't good at logging my food because I'm lazy, so I didn't do it. But based on this different stuff, I built three index. So the BMQ index, which is essentially an average of the way I felt during the day, and then the intensity and the fatigue index. Intensity will be the intensity of the previous day of what I've done before. So it's a factor of distance, elevation, heart rate, and speed. And the fatigue index is a factor of the number of hours I slept and my resting heart rate, right? And so that's the data as it is. And then I needed to figure out a way to take the bundles that I created from CloudBreak and pushing it to a new CloudBreak and also deploy it automatically, right? Being able to say, hey, you know what, just deploy a new cluster that will be able to run my data science. And the way that I did it is using NiFi again. What you can do in NiFi, you can have is you can open an endpoint, and the endpoint is then just running the CLI, and this is just running the CLI from CloudBreak to deploy the cluster itself. And with this, I deployed this one cluster, which is the data science one. And if I go to Zeppelin, the way that this cluster was deployed, it was not only deployed with the suite. It's probably because I didn't have the connectivity. What I'm doing, I preloaded the notebook with all of the things that I wanted to do. So here's what I'm doing in terms of data science. I'm just essentially, so I pushed all the data. I'm creating those indexes. So BMQ index, fatigue index, and intensity index. This is going to be my training set. This is data I'm going to use to train my model. And then I created something that is going to be the estimated intensity index and estimated fatigue index based on parameters that I'm going to enter. So I enter how many hours I plan on sleeping, how well I'm going to feel in the morning, and based on this and my training plans, I'm going to try to predict my fatigue. So for this, I use Spark. Spark is connecting to my SQL database that has been put, and I'm just creating some data frame, trying to normalize the data, and then I'm just applying a linear regression to it. So this is where the magic happens. I run the linear regression, so this is important. All of this is part of the Spark ML. I'm going to touch on the science and the data science itself a little bit later with Data Science Workbench, but let's focus on the data engineering for the moment. I can have this one notebook that is running the linear regression and trying to make a prediction. So I'm verifying that the prediction is correct versus my data set. It's not super good. And let's not look at the the R2 because it's terrible. But so if you look at the model itself, the model is crap essentially. It doesn't predict anything. And I'm going to get to it because I did some work on the correlation and hypothesis testing, and it turns out that I reached the consensus of science, which is we can't predict from objective subjective measures. But anyway, I created this prediction, and then I can get into. So this is just running a notebook in Zeppelin, and because all of this is through an API, I can now create an application that looks at this and then say, hey, let me refresh my model. And so the first thing it's going to do is going to go to CloudBreak and verify that I have a cluster that can run this, right? And if it doesn't, it's going to push it and deploy it. I didn't do it now because it takes about 20 minutes to launch. But let's say I'm going to sleep 6 hours and I'm going to feel terrible the whole time. It's then going to take these inputs push it into Zeppelin. Zeppelin is running the model based on this data, and then downloading back the data using NiFi and pushing it back on my long-lasting cluster. And like you can see now, my BMQ is going to be a lot lower than if I use different parameters, right? So this is kind of the pretty cool stuff that you can do when you have a big H2 AI platform. Is you can take data from there and have an application that automates the consumption, the creation of the model, and bringing it back, right? Make sense? One last thing, because I truly want to look at the science itself. What I did is not only, so this was just a small experiment on my data, but what I really wanted to look at is whether or not my data set would be able to show any amount of prediction. And if this thing, it's just super slow, is it? To resolve the DNS, all right. So what I did is, this is data science workbench that I'm trying to show you. I actually ingested all this data, and I was trying to do what we call a correlation matrix. So correlation matrix will look at your dependent. So dependent is the thing that you're trying to predict with different variables, and trying to figure out whether or not there is some sort of a correlation between variable and the dependent. Now that doesn't prove anything, because correlation not necessarily imply causation. But then there's another step that is a hypothesis testing that looks at. Great, so it doesn't work. It doesn't matter. I'm going to show it to you here. So what I did essentially is like I was saying, I looked at the. So it's the same. It's a Spark job that looks at the data from my data set and trying to correlate so my BMQ with any other measure. And what I found out is they didn't correlate at all. So there was, on the BMQ and the index that I had, usually what you want to get into like the 70% to 90% correlation before you be able to consider building a model around it. And it was like in the 10%. And then I looked at every pieces of data that I had, and what I found is basically the biggest correlation is between speed and distance. So yeah. but even if you look at my sleep patterns and so on and so forth, there was really nothing that did correlate. Now I did a lot more research on this. There's multiple reasons why this could have failed. First of all, obviously the trying to predict subjective measures by just looking at a couple of random objective measures is going to be very hard, because obviously if I'm having a bad day at home or at work or whatever, that's going to affect the way that I feel. It has nothing to do with my training. The other thing is, if you look at the accuracy of those trackers that I don't wear, that just work for the experiment, it's very little, not very accurate. If you compare like the sleep patterns that you get from a Fitbit versus actually looking at your brainwave, which is the right way to do it in the sleep study setting, it doesn't show anything at all, right? It doesn't correlate. Think about it. They're running those small models as well, right? And they're trying to gather a bunch of data to do it, but they don't have a better way to do it than I did, right? But one thing that I want to tell you is, if we are able to find a way to predict the way that the athletes feel, this is going to solve a lot of things in the recovery in the athletic world. This is why, I don't know if you started looking at, a bunch of application like Strava or Training Peaks that I'm using, for instance. They will ask you how you, or Daily Mile or whatever, they will ask you always how you feel after a run on a scale and the perceived effort and etc. They're trying to build this. Obviously, they have a much larger data set because they have a whole pool of people doing it, but they're really trying to figure this out. And there is a lot more. If you're interested in the topic, you could read a book that's called Good to Go. It's a very good overview of the science of recovery specifically and its importance in training. And there is a lot more emphasis in like the Sixers and like the real professional athletes are looking at mood more than looking at the HRV or whatever fancy gadget. So if you are interested in improving your performance, look at the way that you feel. Right now, I don't have a way to predict it. That's basically it. All right, that was 30 minutes.
Are you winning races with this?
I won the race here 3 weeks ago. So,
Really?
there you go.
Do you have any more here?
What?
Do you have any more races around here?
Well, yeah, I'm running a marathon in like an hour from here and in a week or so. So yeah, and I'm gonna try to win. We'll see. All right. I think you say as much as you guys want, but if you have any questions, let me know.
Does it help you to eat better or manage your rest patterns better? Are you learning from what it's learning? Or?
Yeah, so no. I'm gonna be honest. Like, I started like running 6, 7 years ago now. What I found out is it's important to. I have only a limited amount of things that I can stress about. I choose not to stress about because if you actually look at the science for food specifically. Everybody wants to give you like the right option, but if you look at Usain Bolt, for instance, when he won three times in a row the gold medal, he was eating 20 chicken nuggets every meal, right? So it doesn't matter where you get the nutrient as much as how much you're getting for what you need. So I try to focus on more the quality of the food that I'm eating. Rather than obsessing over, nonsense diet fads and stuff like this. And the hardest part for an athlete is to learn to listen to your body.
Yeah, I was going to say listen to your body.
Yeah. So that's eat, drink when you're thirsty. Eat whatever you feel like eating. To an extent. But then that should be the. If you're able to do this without stressing it out, then it should be good to go.
All right, thank you.
Yep.
Just say quick before we close, thanks for coming out. I'd love to see you next month for the pizza pitch competition. Anybody with relevant community updates? Anybody looking? Yeah.
No, I'm just going to say that the Knife 5 is very interesting to me. I'm building little devices, the clients, and I just don't have the scalability, but I do now.
Yeah.
Good. I have a demo out it's called IoTdemo.online, and that's where my minions are sending their data.
Yeah, and go to Horton Work Community. All of the stuff that I did is there. And a lot of tutorials on IoT and i5 Mini 5 are going to be there. So definitely I'm going to encourage you to check it out.
And there's a guy named Tim Span, there's a meetup in Princeton,
Yep.
Future of Data, and the guy named Tim Span is probably like one of the best Wi-Fi experts in the world.
Yeah,
and he's there all the time.
Yeah, he's going to Philly in June, and I'm hosting the Future of Data in Philly. So if you guys want to swing by, just check me out.
I would have brought him up here, but he had to go speak in a conference in Barcelona.
Yep.
So,
Yep.
is he from Princeton? He lives near Princeton.
Yep.
And please take free stuff,
Yeah,
including
still-
pizza and soda.
T-shirts in the back, soda, pizza.
pens and earbuds. So
Thanks for coming out.
thanks for coming out. Yeah. Thanks for working. Thanks. Yeah. Well,